So the next way that I want to solve a system is through elimination method. Sometimes it's also called the addition method or addition property, only because as I'm eliminating, I'm going to be adding to do so. So some books call it different things, right? Now, with our elimination method, the reason that we might want to do this elimination method is because when we solve using substitution, say for example, I wanted to solve an equation, and in solving for a variable, I ended up with a fraction. Now, some people might be okay with fractions, but lots of us do not like dealing with fractions. So, because I could end up getting a fraction when I am solving with substitution, which means that not only do I have a fraction, but then I'm gonna have to plug back in a fraction. Oh, it's too many fractions, right? So this idea of elimination method, that will help me from having all of these fractions, okay? So it's just another type of way that I can solve. Any of these ways work no matter what. So substitution will always work. It might be ugly, but it'll work. Elimination will always work. It might be ugly, but it'll work, right? So let's look at this type of a method when we're solving here. So again, I'm going to write down a problem. We're going to solve it and talk about the different steps as we go. I think it's a little bit easier to understand. So let's look at our first example. Let's say we have negative 2x minus y equals negative 9. Then we have 5x minus 2y equals 18. All right, so there's my system. Now, with elimination, the name elimination tells us what we want to do. We want to eliminate a variable, okay? The way we're going to eliminate a variable, think about whenever, just a second ago, whenever we had the solution, no solution or infinite solution, right? Our variables canceled off. The way it canceled off was I had a positive 3x and a negative 3x. So the way we're going to get a variable to cancel is that variable has to be the same number but opposite signs from one equation to the next. So looking at this example here, if I choose to eliminate my y's, what that means is that one of the y's must be a positive of that number and one of the y's must be a negative of that number. Well, the number that we see here is 2, all right? So if I wanted to get rid of a negative 2y, then I would need to have a positive 2y in my equation. So that's what we're going to do. We need to get a positive 2y in this spot. The way we're going to do that is I'm going to multiply that entire equation. So if I think about this is a negative 1 here. What would I need to multiply negative 1 by to get a positive 2y? Well, I would need to multiply that equation by a negative 2. Because if I take negative 2 times negative 1, I would get positive 2. All right? So I need to multiply this entire equation by negative 2. So let's do it. If I take negative 2 and multiply by negative 2, I'm going to get 4x. If I take negative 2 and multiply by negative 1y, I'm going to get positive 2y. If I take negative 2 and multiply by negative 9, I get positive 18, right? Now, I didn't do anything to this second equation, so I'm just going to write it down. Right? So, I've completed that first step, right? That first step was to pick a variable, to cancel, multiply if I need to, and I did. So the next step says I'm now going to add these two together. So let's go ahead and add these two functions, these two equations together. When I add them together, I'm going to get 9x. My y's will cancel. If they do not cancel off, then I did not truly eliminate in that first step, right? I did not find the correct numbers to be able to eliminate, because now I see that my y variable is gone. And now I can add 18 plus my 18 will give me my 36. So now this is a super easy equation to solve. So the next step says I'm going to solve for this variable, right? So all I need to do now is divide by 9, and x is equal to 4. Perfect. So now I have found my first solution. Now, even though this is not our substitution method, I do substitute at the very end. So now what I'm going to do is I'm going to take this answer of x equals 4, and I'm going to go back to either of my two equations and plug it in and solve. Okay, so let's just say, for example, I decided I'm going to pick the first equation. So I'm going to pick equation 1. So I'm going to say negative 2 times 4 minus y equals negative 9. And I'm going to solve this equation for y. Again, I could have picked the second equation, but I pick whichever equation I want, and then I go solve. So I'm going to get negative 8 minus y equals negative 9. Add that 8. So I'm going to get negative y equals negative 1. Divide by that negative 1. So y is going to equal 1. Right? So now I have both of my variables. I've got my x variable and I've got my y variable. So I can write my ordered pair is going to be 4, 1. All right, again, I write it as an ordered pair because it is a solution to that system. Okay, so we're going to go through that same process again just to make sure that we're understanding what's happening. All right, so let's say that we have the equation negative 5x minus 8y equals 17. 2x minus 7y equals negative 17. Okay, so here's my system this time. So remember, I'm going to start off and I'm going to ask myself, well, which variable do I want to get rid of? Now, the last time it was kind of easy because I had one variable that was already kind of by itself. But when I look at this, I need to think about the combination, right? Remember, we want to get the same number but opposite signs, right? So my goal is same number, opposite signs, okay? So let's think. I'm going to have to multiply to be able to get that. So if I look at my x's, between a 5 and a 2, the least common multiple of that is going to be a 10, right? I can multiply 2 by the 5 and 5 by the 2, and I would get a 10. If I look at my 8 and 7, the least common multiple would be 56. So you're right. I could technically pick either one of these. But for me, remember, I like the least amount of work. So I'm going to go for the smaller number. So I'm going to pick x to eliminate. All right? So when I decide that I'm going to pick x, that means that they both need to become 10s. One's positive and one's negative. Well, the 5 is already negative, so that works out perfect. So I need to think about how, using multiplication, can I get the 5 to become a 10? Well, I would need to multiply here by a 2. For the 2 to become a 5, for the 2 to become a 10, I would need to multiply by 5. So I'm going to multiply each of these equations here. So let's look at the first equation. Multiplying everything by 2 is going to give me negative 10x minus 16y equals 34. All right, looking at my second equation, I'm going to multiply everything by 5 now. So I'm going to get 10x minus 35y equals negative 85. So now I've multiplied so that my x's are both the same, remember my goal, the same number but opposite sign. So at this point, I can now add the two equations together. When I do that, those x's better cancel, and they do. I'm going to be left with a negative 51y and a negative 51. Then all I'm going to need to do is solve for y. So I'm going to divide by a negative 51. So y is going to equal 1. So even though the numbers got a little bit big, right, we had 85 and there we had 51, it ended up not being so bad when I actually solved. So now I'm going to take that 1 and I'm going to take it all the way back up to either of my two equations. So let's say this time that we want to pick equation 2, just only because we picked equation 1 last time. So let's say we want to pick equation 2. So I'm going to go back up and I'm going to say 2x minus 7 times 1 equals negative 17. And I'm going to solve this now. So I have 2x minus 7 equals negative 17. I'm going to add that 7. So I get 2x equals negative 10. So x is going to equal negative 5. So now I've got my two solutions. I've got my x and my y. So my ordered pair, my solution would be negative 5, 1. Remember, we would write that as our ordered pair. Okay, so now I can see how to do this elimination method. Sometimes I maybe just have to multiply one equation. Maybe sometimes they're already ready. I already have the goal that I'm looking for, which is the same sign, or excuse me, the same number and opposite signs. If not, I'm going to need to do some math. I'm going to have to multiply the entire equation by whatever I need to get there. Okay. Now, just like last time when we looked at substitution, I want to show you what it would look like if I end up in one of those special types of solutions where I either have no solution or infinite solutions. So let's look at what it might look like. Okay, so let's say we had one more example here. And let's say our equation was 2x plus 4y equals 18. And negative x minus 2y equals negative 9. Right, so here's our system. So we start off exactly the same as we had done before. We look at the equations and we say, okay, well, what would we want to eliminate? This case, it's not so bad. I'm just going to go ahead and pick x. So I need to multiply the bottom equation by a 2 so that I could have a positive 2x and a negative 2x. All right, so let's do that. I'm going to leave the first equation alone. But I'm going to multiply that second equation by 2. So I get a negative 2x minus 4y equals negative 18. All right, so once I've done that, I'm now going to add the 2 together. My x's should cancel, but my y's also cancel. What that means is I have a 0 here. Everything canceled, so I have 0. So then the question here is what happens to my answers on the other side of the equation. If I get in 0, which I did in this case, we would have infinite solutions. Because remember, does 0 equal 0? That is a true statement. So I would say infinite solutions. However, what if we had done this and here it had been a 19? So 18 plus 19, right? I do not get a 0 here. So if instead I had 18 and a negative 19, I would have had a negative 1. So we would have said, does 0 equal negative 1? We would have said no. If we have a false statement, remember that's going to be the no solution. All right, so I can see the same thing as we did in our last way to solve. If when I'm solving, all of my variables go away, not that I get the number 0, but if all of my variables go away, then we have to ask ourselves, do we get a true statement or do we get a false statement? Okay. And that will tell us if we have infinite or no solutions. Okay. So now we should be able to solve not only through substitution, but also through this elimination method. Like I said, both ways work. It's up to you to decide either which way you like better or which way better suits the equations that you have.